Today is lesson 4 on mutually exclusive and non-mutually exclusive events. The definition of mutually exclusive events is events which cannot happen in a single trial. So they have no common parts. So for example, mutually exclusive events would be flipping a 7 in a deck of cards and flipping a 10. So if I flip a card, it cannot be both at the same time. It's either going to be one or the other. So to warm up, we would have seen a question like this before. What is the probability of rolling a 3 or a 4 with a dice? So the probability of rolling a 3 or a 4, remember that we take our favorable outcomes and divide it by our total outcomes. So when you roll a dice, you can get a 1, 2, 3, 4, 5, or 6. So our favorable outcomes is going to be 2 of them, right? A 3 or a 4. So 2 are favorable out of a total of 6 options. So probability equals 2 out of 6. Remember that we like to have our probability in simplest form, so the probability would be 1 over 3. So that's not new, however, we are going to attach that to a formula. So if we think back to our set theory unit, we knew that the union of an event meant or. So here, when we have union, it means the probability of A or B. And or, we also remember from our previous unit that or means add. So anytime we're talking about this or that, we are going to add the probabilities together when the events are mutually exclusive. So I have that down below, but this is the formula for mutually exclusive events. So in the case of our dice example, we would write it as the probability of a 3 or 4 using our union notation. So we could add the probability of a 3 plus the probability of a 4. So 1 out of 6 plus 1 out of 6 gives us that same answer of 1 out of 3. So today we're going to spend some time using that formula and also look at what happens if the events are not mutually exclusive. So remember, mutually exclusive means that they cannot happen in a single trial and that they're not related to each other. Okay, I have kicked my cat outside, so hopefully there will be less meowing for a little bit. Let's try the next example. Single die is rolled. What is the probability of rolling a 2 or a 6? So using our notation, it's very similar to the last question, but we're looking for a 2 or a 6. 2 union 6, which means that we can take the probability of rolling a 2 and add it to the probability of rolling a 6. Each of those has a 1 in 6 probability, so our probability of rolling a 2 or a 6 will be 1 out of 3. Remember, adding fractions is very different than multiplying fractions. For adding fractions, we have to find a common denominator. So if you're really confident with finding a common denominator, go ahead and do that. Otherwise, just type it into your calculator. Remember to put brackets around your fractions with the addition sign. Next example. A single card is drawn from a standard deck of 52 cards. What is the probability of drawing a red card or a black queen? So we're looking for the probability of a red card or a black queen. And I know this notation, I'm just making it up, right? I'm using the first letter to make that up. The red card or the black queen. So keeping in mind that these cannot happen in the same event, right? A red card and a black queen, they're always going to be different events. So I can find this by taking the probability of finding a red card and adding it to the probability of a black. So probability of a red card, well, that's half the deck, which is 26 out of 52. And then the probability of a black queen. There is a king of clubs and a queen of clubs and a queen of spades. So 2 out of 52. That gives us a total of 28 out of 52, which can be simplified to 7 out of 30. Remember that when you do convert it back to a fraction after you're done on the calculator. Next example. Card is drawn from a deck of 52 cards. Use the formula to determine the probability that a 9 of diamonds or a heart is drawn. We are looking for the probability of a 9 of diamonds try that again. Or a heart. So a 9 of diamonds or a heart. Let's take those. And because it is a union, we are going to add the probabilities. Just a reminder that this formula is on your formula sheet. You just have to apply it to the context of the question. So the 9 of diamonds, there is only one 9 of diamonds in a whole deck. And a heart, there are 13 out of 52 hearts. So we get 14 out of 52, which simplifies to 7 out of 26. For our probability of a 9 of diamonds or a heart. Next example. 2 cards are drawn without replacement from a deck of cards. What is the probability that they are both our heart or both our spades? So a couple different things here. First off, this is without replacement, meaning that these events are going to be dependent on each other. We take a card out and it's going to affect outcome B. And we are also have the OR statement here. So we're looking for the probability that they are both hearts or probability that they are both spades. So thinking back to the lesson yesterday, if I'm finding the probability that they're both hearts, I'm going to multiply those probabilities together. So the probability of one heart is 13 out of 52. Then I have taken a card out and I have not put it back. So I now only have 12 hearts out of 51 cards. So that's for the both hearts. And then the OR means add. So we're going to add that to the probability of both spades. Now the both spades calculation actually looks exactly the same. 13 out of 52 times 12 out of 51. So because that OR is there, we don't take into account, it's not like we're pulling 4 cards, right? It's either we're getting 2 hearts or we're getting 2 spades. So type that in on your calculator and you will get 2 out of 17. I'd like you to pause the video and just make sure that you can get that number of 2 out of 17 on your calculator. Next example before we move on to non-mutually exclusive events. two cards are drawn without replacement from a deck of cards, what is the probability that they are both kings or both queens? So we are looking for the probability that we get a king and a king, so both kings, or the probability that they are both queens. So remember that the and means multiply and the or means add. So the probability of my first king is going to be 4 out of 52. Because we did not replace that king that we just drew, we now only have 3 out of 51 cards. And we are going to add it to the probability that they are both queens. There are 4 queens in a deck of cards. And we have now taken one of them out. And we have to divide by 51. Okay, the answer here is 2 out of 221 as my final probability. So now that brings us to our definition of non-mutually exclusive events. These are events that can happen in single trial at the same time. So if we can think about it in terms of a Venn diagram, it would mean that there's overlap between the two events. So for example, if I said draw hearts or draw nines, those are no longer mutually exclusive. They're non-mutually exclusive because we have the the 9 of hearts. So this formula, once again, is on your formula sheet, and it will be used to calculate the probability of non-mutually exclusive events. So it looks slightly different. We are still adding because of that word or. However, we are subtracting the overlap. The reason that we have to subtract that overlap is because we included those two numbers in there twice. Let's try a few examples. First example says, when randomly selecting a card from a standard deck of playing cards, what is the probability of drawing a 7 or a heart? So if we start this the same way as our last question, we would write, okay, we are looking for the probability of a 7 or a heart. So we know that we have to find the probability of a 7 added to the probability of a heart. However, we run into a problem here, and that is that there is a 7 of hearts. These events are not mutually exclusive. So that means we have to subtract the overlap. So the overlap, once again, just picture that Venn diagram. Are there any cards that would be included in the intersection that would be both a 7 and a heart? And yeah, there's one card. So the probability of a 7, that's 4 out of 52. Probability of a heart is 13 out of 52. However, if you look at those numbers, where they came from, we had a 7 of heart, diamond, club, and spades, and then we had all the hearts. So that 7 of hearts was included 2 times. So all we have to do is subtract one of them so that we don't double ding ourselves for it. Okay, so we have 4 plus 13 is 17 minus 1 is 16 out of 52. 16 out of 52, type that in on your calculator and math bracket, we get the final answer of 4 out of 13. So these events, once again, are not mutually exclusive or non-mutually exclusive. because you can have something happen in the same trial. You can have that 7 of hearts happen in the same trial, which is part of both of those events. Right, next example says, what is the probability of rolling a 2 or an even number on a die? Okay, so we're looking for the probability of a 2 or an even number. So if you think about your dice, you have a 1, 2, 3, 4, 5, 6. So you're looking for the probability of 2 plus the probability of an even, but then you have to subtract the overlap because there is one that is 2 and even, and that of course is rolling a 2. So the probability of rolling a 2 is 1 out of 6. Probability of rolling an even is 3 out of 6. And then minus our 2 and even, that's 1 out of 6. This one's interesting because 2 is an even number, but we get the answer of 3 out of 6 or 1 out of 2. Okay, we have one more example to go. Jason rolls 2 dice. What is the probability that his roll results in a sum that is greater than 8 or multiple of 5? So we're rolling 2 dice and we're looking at the sum. The only way to do questions like this is making that sample space. So we did this the first class, where we talked about dice number 1 on the top. Dice number 1, you could roll a 1, a 2, a 3, a 4, a 5, or a 6. And dice number 2, same thing. So you have to look at all of the possible outcomes. So if you rolled 2 ones, your sum would be 2. If you rolled a 1 and a 2, your sum would be 3. And a 1 and a 3, your sum would be 4. So go ahead and fill in this table so that we can answer our question. All right, I have finished my sample space. So now I'm going to go ahead and highlight what I'm looking for. I'm looking for a sum that is greater than 8. So 8 is not greater than 8. So that will include 9s, 10s, 11s, 12s, and then it says or a multiple of 5. So I'm going to go ahead and I'm going to shade these ones in purple. So remember, multiples of 5 or anything, skip counting by 5. So that's going to include the 5s and the 10s. So the 10s, obviously, I have shaded in twice. So that's where this formula comes in place, right? We'd add the probability of the greater than 8, we'd add the probability of 5, and then we would have to subtract 3 out of 36 because those 10s were shaded in twice. However, when we have drawn this beautiful sample space, you don't have to do all that because you can just count them up. I'm going to show it to you either way though. Okay, so our probability of growing greater than an 8 or a multiple of 5 is going to be equal to your probability of greater than 8 plus your probability of a multiple of 5 minus the probability that it is greater than 8 and a multiple of 5. So we had 4, 5, 6, 7, 8, 9, 10 that were greater than 8 out of 36. We had 7 that were multiples of 5. And then we need to subtract the 10s there, the 3 out of 36, because we accounted for them 2 times. So that gives me the answer of 14 out of 36. Which would simplify to 7 out of 18. So for a question like this, you do have the luxury of just counting up everything you have highlighted. Just make sure you don't count those tens twice.